In this video, we are going to be discussing significant figures. We are going to learn how to identify them in a measured number and how to use them in mathematical operations. Understand that significant figures are specific to measured numbers. These digits are the ones that carry meaning when we have a measurement because they're the ones that are present as part of the resolution of a particular instrument. As you can see here, we have the rules to determine if a number is a significant figure or a significant number, and they are summarized in table 2.2 in your textbook. So let's go through the rules. I'm just going to zoom in into the table so we see them more closely. So when it comes to the rules, the first rule is that a number is a significant figure if it's a non-zero digit. So for example, in the value 4.5 grams, we have two significant figures. In the measurement 122.35, again, we don't have any zeros. In this case, this measurement is in meters. We have 5 significant figures. So again, if you have a series of numbers and they do not include a zero, all of the numbers are going to be significant. Now, another important thing that we should determine is when is a zero significant? And this is when the rules 1b, 1c come into place. A zero in between non-zero digits is going to be a significant figure or significant number. So as you can see, if we have the number 205, in this case meters, that contains 3 significant figures. If we have the number 5.0008 kilograms, that contains 4 sig figs. Now, if we have a zero that is at the end of a decimal number, but let's specify that this zero at the end of a decimal number must trail or follow non-zero digits, then those zeros are going to be significant. In addition to that, and I'm just going to highlight it in red, we must have a decimal place must be written. So we have two, in addition to rule 1c, we have two more statements that are attached to rule 1c. Okay, so for example, where we have the measurement 50 or 50 decimal place, and in this case it's going to be liters, that's why we have two significant figures. 25.0, 3 significant figures. 16.00, 4 significant figures. Now, when we have a particular number and it is written in scientific notation, the values that are present in the coefficient are going to be the ones that carry meaning or are significant. So that's what you can see in the value 4.8 times 10 to the 5 meters, there's 2 sig figs because in the coefficient there are 2 digits. In the value 5.70 times 10 to the negative 3 grams, the reason why we have 3 sig figs is because those are all the values that are present in the coefficient. So I'm just going to write a note that when converting a numerical value to scientific notation, you must keep the number, and that pound sign is my symbol for number, the number of sig figs given. You must also keep it in the coefficient. So if we go back into the examples that we did for the conversion of scientific notation, we can see this illustrated. the reason why the values are the responses that we discussed previously. So please go back and review that. Then there are some instances in which zeros are not significant, and those are the rules on number 2. So a zero is not significant if it's at the beginning of a decimal number. But there is another thing that we should take into consideration. If these are at the beginning of a decimal number, meaning that they are before the first non-zero digit, then they are not significant, okay? Because in this case, they are just placeholders. They're just telling you that this number is very small. So as you can see, in the value 0.004 seconds, we only have one sig fig because those zeros are before the first non-zero digit. In the value 0.075 centimeters, we have two sig figs because again, the zeros before the non-zero digits are not significant. Now, another way in which the zeros are not significant, again, if they are placed as a placeholder in a large number, meaning at the end of the value. So for example, in the first example where we have 850,000 meters, we only have two sig figs because the zeros are going to be after the non-zero digits and there is no decimal place written. In the value 1,250,000 grams, as you can see, only three sig figs because the zeros there are just placeholders. They're just telling us that we have a very large number. Please do not confuse the term significant with relevant, because I know that in everyday life we may use the term significant to give it meaning to something. And in this case, significant does not mean that they are not important. So what we do with significant figures, remember that this is attached to the numbers that carry meaning in the resolution of a measured number. Now, let's now go over these examples. So this is problem 3 in the worksheet, and let's determine the number of sig figs present in each of these values. So significant figures, sometimes we just write SF. So just in case if you see that in lecture or in the notes. So as you can see here, we have the number 246.32 that has 5 sig figs because they're all non-zero. As you can see, 107.854 that has 6 sig figs because again, the zero is significant in this case is between non-zero digits. In the number 100.3, we have 4 sig figs because the zeros are in between non-zero digits. In the number 1.008, we have 4 sig figs. Those zeros are in between non-zero digits. In the value 0.00340, we have 3 sig figs because the first set of zeros, okay, are just placeholders, okay? The last zero is significant because it is after the non-zero digits and after the decimal place. The value 14.600 has 5 sig figs. The value 700,000 has 1 sig fig because those zeros are just telling you the quantity. They're just telling you that there's a very large number. In the number 350.670, there's going to be 6 sig figs. And lastly, in the number 1.0000, there's 5 sig figs. And again, the zeros in this last value are all significant. The 1 because it's a non-zero digit, but the zeros are significant because they are after the decimal place, after the non-zero digit. Now, the next topic that we're going to be discussing is exact numbers. And the reason why we go exact numbers is because exact numbers are going to be utilized in this chapter in order to be converting from one unit to the next. So what are exact numbers exactly? Well, these are numbers that are not measured and they do not have a limited numbers of sig figs. they actually have an unlimited number of sig figs, okay? So when we use them, mathematical operations, which is what we're going to discuss further in this chapter, they do not affect the number of significant figures in the calculated value. Now, what are examples of an exact number? Well, the first example will be if we have a number which is obtained by counting. So to give you guys an example of a number that is obtained by counting, it will be 1 dozen. And 1 dozen equals 12 objects. Now, ideally, when we think of these numbers that are exact, then if you think about the significant figures, it would be like 1 dozen equals 12.00000 infinite zero objects. That's why we don't count them. Another example of a number that is an exact number is going to be when we have two units that are compared, okay, in the same measuring system. And again, we're going to discuss that further when we talk about prefixes and equalities. Now, another thing that it is important is that specifically when we go into the next topic, which is significant figures in mathematical operation, you guys have to keep in mind the rounding rules. And as you can see, if the first digit to be dropped is 4 or less, then it and all the following digits are dropped from the number. What does that mean? That whenever I'm rounding, I'm going to look at a particular value. If that value is 4 or less, then it and all the following digits are dropped from the number. There are times in which we'll convert them to 0 just because of the quantity that we're looking at, but we will look at that in examples. Then the second rule of rounding is if the first to be dropped is 5 or greater, then the last is retained, the last digit is retained for and the number is increased by 1. Again, these are just rounding rules that you guys have explored before, and we are going to utilize them when doing mathematical operations. So let's discuss now the rules for significant figures when we're doing addition or subtraction, followed by multiplication and division. So first, when we're doing addition and subtraction with significant figures, understand that the final answer, okay, is written so that it has the same number of decimal places. Let's just highlight that. The same number of decimal places as the measurement with the fewest decimal places. So let's say that we have to add these 3 values. As you can see, the first value has 3 decimal places, second value 2 decimal places, and lastly, last value has 1 decimal place. What does that mean? That even though we add these values and we put them in the calculator, remember that your calculator doesn't know sig figs. Your calculator display will be the number that is shown in the calculator, and it is your job to round these values to the correct number of sig figs. In this case, because we are doing addition, understand that the answer must be rounded to the 10th place, meaning to 1 decimal place. So even though this is your calculator display, again, to review rounding rules, we are going to look at the first decimal place, we look at the neighbor. This is a value of 0, and because it is 4 or less, then that means that these 2 values will not be included. So your final answer is 66.1. Now, let's look at the rules for significant figures if now we have multiplication and division. When it comes to multiplication and division, understand that the final answer is written so that it has the same number of significant figures as the measurement with the fewest significant figures. So what does this mean? For example, let's say that here we have 2 measurements. We're multiplying 24.66 centimeters times 0.35 centimeters. Again, when you take these numbers and you put them in the calculator, your calculator is going to show the value of 8.631, okay? But if you have to round this value to the correct number of sig figs, by looking at these two values, you should identify that the first measurement has 4 sig figs. Second measurement has 2 sig figs. So your final answer needs to have 2 significant figures. So again, when it comes to this, I'm just going to highlight it in yellow. The 2 sig figs that I have is that 8.6, but looking at my rounding rule, the reason why the final answer is 8.6 is because the number next to 6 is a 3, meaning that it is 4 or less. So that means that these two numbers are not going to affect the 6 and will not be included in the final answer. Now, to review on how to do significant figures and measurements, as you can see, I'm going to do the problems that are to the left of this worksheet. So I'm going to do this addition. I'm going to do letters A, B, and C. Okay, so in the first number, okay, as you can see, we're going to be adding. We're going to be adding specifically 32.567, 135.0, 1.4567. Okay, when we do this, understand that your calculator display is 169.0237. Okay, and understand that in exam and quizzes, I'm not going to request what is the calculator display, what is the final answer. You just submit the final answer. So even though this is the calculator display, when we look at the rules for sig figs, remember that the rule in this case is going to be decimal places. So I have 3 decimal places, 1 decimal place, and lastly 4 decimal places. So my final answer needs to be rounded to 1 decimal place. So that means that my final answer for this problem is going to be 169.0. Let's move on to letters A, B, and C. On A and B, we are going to have multiplication and division. So in this case, we are going to be looking at what are the sig figs in the values that are multiplying or dividing. And then my final answer has to have the same number of sig figs as the measurement with the lowest number of sig figs. So when we look at the first multiplication, 23.7 times 3.8, this has 3 sig figs. This has 2 sig figs. That means that my final answer needs to have 2 sig figs. So when I multiply these two values, even though my calculator display is 90.06, if I want to express it or round it to 2 sig figs, I can write it as 90 decimal place, or I can choose to write it in scientific notation, 9.0 times 10 to the 1. Let's look at letter B. We're doing division. Again, similar to letter A, we're going to be looking at the number of sig figs. The first value has 4 sig figs. The second value has 2 sig figs. So my final answer needs to be expressed into 2 significant figures. So when I divide 45.76 by 0.25, my calculator display is 183.04. So that means that when I write my final answer, I need to round to 2 sig figs. So this value I'm going to round to 180. Okay. Lastly, I want to give you an example in which we're doing combination, meaning we have to follow PEMDAS rule. So for those of you that are not familiar with PEMDAS rule, PEMDAS rules have to do with order of operation, in which we have P is for parentheses, E is exponents. M is multiplication. D is division. A is addition, followed by subtraction. So if you have these, then you have to follow PEMDAS rule in order to solve the problem. So let's actually go over the problem that we have specifically here. And I'm just going to erase the notes that I just did. The PEMDAS rule, so I have space to solve the actual problem. So when it comes to this, again, based on PEMDAS rule, that means that I'm going to do the parentheses first. So because I have to do the parentheses first, I have to keep in mind, hey, from the parentheses, the rules that I have to apply are going to be decimal places because I'm adding. So that means that in this case, I have to look at this value and tell myself, hey, this has 2 decimal places. This has 1 decimal place. So far, coming out of the parentheses, I need to make sure to keep track of my decimal places in my value. So when you put these numbers and you add them in the calculator, then you will get 107.77, okay? Now, because these came out of a parenthesis in which we're adding, then that means that we are going to take note that ideally this number, it's only going to include the values up to the first decimal place. Now, please do not round at this point. You're just keeping track of the values that are important based on the significant figures rules that you're doing based on the operation that we're doing mathematically, okay? That's all we're doing. Now, when it comes to this, then you have to tell yourself, okay, since the value technically that I'm paying attention to is the first 4 digits up to that first decimal place, that means that those are the ones that I'm going to be paying attention for the next operation, which is division. And in this division, understand that then you're going to tell yourself, because the values that are important based on the first rule are the ones that I circle in orange, because my next operation is division, then I have to keep track of, like, based on what I highlighted in orange, how many sig figs I have there, because I'm going to be doing division. Now, in this case, you're going to tell yourself, well, here I have 4 sig figs, even though you see written 5. Remember, the only reason why I'm laser focusing on the 4 is because I applied to it, okay, the rules based on the operation that is in the parentheses. Please don't be confused by that. Then, looking at this division, then I say, hey, this has 1 sig fig. So that means that my final answer needs to be to 1 sig fig. So when you do your calculation, okay, then what you're going to do is round your value to 1 sig fig, which in this case, the final answer is going to be 500.